All right, so I'm going to start the hyperbola stuff by basically talking you through what all of these words mean. There's lots of labels, lots of pictures going on, and just like ellipses, these are of course color in the book, which would make things a little bit easier, but I'll see if I can talk you down a little bit and make some of this stuff a little easier. So a couple of the words are familiar from ellipses. We've still got a focus here, foci, or however it is that we're supposed to be pronouncing that. And then we've got vertices still, and we also sort of have co-vertices, although they're not really part of the hyperbola. So instead of having a minor axis and a major axis, so what ellipses have, the major axis is always the longer of the two, and then the minor axis is always the shorter of the two. When we're talking about hyperbolas, we don't distinguish between which one's longer and which one's shorter. We distinguish between the direction that they're going in. So this one, for instance, that we've got right here, that's a horizontal hyperbola. All right, so this one is horizontal. Just throw a quick label on there, which means this one is vertical. So when we distinguish between which one's horizontal and which one's vertical, it means this is opening in a horizontal direction, opening along a left and right line, whereas this one is opening in a vertical direction or opening up and down like that. So what the transverse axis is, the transverse means like laying along something. So you might talk about like a bar being like a transverse bar on a bridge or something like that. So transverse means that it lies along the axis that the hyperbola corresponds with. So the hyperbola is horizontal, so the transverse axis is the horizontal one. And since this is a vertical hyperbola, the transverse axis is the vertical one. And then the conjugate axis, remember the conjugate kind of means like opposite. We've talked about conjugates before. So the conjugate axis is the one opposite the transverse axis. So since this is horizontal, the conjugate is the vertical axis. And since this is vertical, the conjugate is the horizontal axis. All right, so just a couple of quick notes that we can kind of keep in mind there. I just want to jot down a couple of things. There are two axes of symmetry, just like before. Meaning you could fold that hyperbola in either direction, it would be the same. And then we have these vertices and co-vertices. The vertices are always at the end of the transverse axis. And then the co-vertices are always at the end of the conjugate axis. Okay, so basically the same axes of symmetry that you had before. So you could see if I use this line and you folded the hyperbola over, it'd be perfectly symmetrical. Or if I use this line and you fold the hyperbola in half, it would also be perfectly symmetrical. So just kind of an intro there before we get into kind of the nitty-gritty stuff with the formulas, similar to what we had with the ellipses. Okay, so if we flip, we're going to start with the generic one. So this is just x squared, y squared, x squared, which means these ones are centered at the origin. Okay, so these ones are centered at the origin. So just like ellipses, we're going to kind of baby step you there. We're going to start with the simpler ones, then we'll worry about changing the origin. So this one, when the x squared comes first, when it's the x squared minus the y squared, that format tells you that it's going to be horizontal. Okay, and the horizontal ones look like this. Okay, now these ones, when the y squared comes first and then minus the x squared, these ones are going to be vertical, and the vertical ones look like this. Okay, now the foci, same exact places that you would find them in an ellipse, so still plus or minus c, comma 0, and then 0, comma plus or minus c for this. And let me show you just back on those pictures here. So this one, see, there's the focus. There's the focus. You change the x value, but the y value is 0 when you're talking about a horizontal one. Here's the focus. Here's the focus on the vertical one. So you change the y value, but not the x value. The x value is 0. So that's why we have these formulas right here. Then we have the transverse axis. So for the horizontal one, the transverse axis is horizontal, and it's 2a units long. So whatever value you have down here, you square root it, that's a, and then twice that would be the transverse axis. Same thing here, it's 2a. And then let's also throw in the vertices. If you're centered at the origin and you're going a units to the left and a units to the right, the vertices would be at plus or minus a, and then still just a y value of 0. Here you'd go a units up and a units down to get to your vertices, and that's like this point and this point right here. So the x value is 0, but for y you go up or down a. Okay, and the conjugate axis, remember, is the opposite one. So with the horizontal hyperbola, the conjugate axis is vertical. It has a length of 2b. Notice b right there. This conjugate axis would also have a length of 2b. Let's squeeze in the co-vertices here. Sorry for not typing that out. So here you go b units up and down because this one goes vertically. So the x value is 0 and you go b units up and down. Here, since it's vertical, the conjugate axis is horizontal, so you go b units left and right. Okay, so that'll be helpful. And then lastly, we have these asymptotes. And I want to point these out to you. Can you see on here? Now, these did not copy very well out of the book. So you know what? I'm actually going to throw the book under here really quick just so you can see. And it's nice to see they're all in different colors too. If you see this one, this is supposed to be a dotted line. It didn't copy as a dotted line for some reason. So these are the asymptotes. We've got an oblique asymptote right here, and we've got an oblique asymptote right here. Now let me explain where this comes from. Here, if you think like slope, start from the center and go to this point. You go up b units, and then over to the right a units. Because we know we're going up b units to get here, we know we're going over a units to get here. So we go up b over a. So that's a slope of b over a. So our asymptotes, we've got slopes of plus or minus b over a, and then times x. All right, so that's just the slope. And then if you look at this one goes in the opposite direction, so it goes down b to the right a. Now if we look at the vertical one, for the vertical one, A takes us to the vertex, so we're going up A to the right B, so that would be a slope of A over B, or we go down A to the right B, so that would be a slope of negative A over B. So for the vertical ones, our two asymptotes are plus or minus A over B. Remember, just like I've been saying the last couple sections, do not freak yourself out too badly with these formulas because you'll have them. Okay, a couple of notes really quickly here. One note that I wrote on the previous page. There are two axes of symmetry, so we already wrote that down. Sorry for repeating it. Oops, But if I didn't write it here, then there would be a blank spot right here, and it would look like I was unprepared with how many notes I wanted to give you. And then the values of A, B, and C. So A helps us find the vertices, B helps us find the co-vertices, and C helps us find the foci. They are related by c squared equals a squared plus b squared. So that's different from how the ellipse is related. So if you look right here, if you compare, so like here's the value of a, here's the value of b, and then when you move this focus out here, it's forming a different right triangle than the ellipse one was. And so these are related like this. So this would be something that you'd be able to have in a formula sheet as well. Okay, so these first two, these ones are still pretty basic because we're centered at the origin. We are going to write an equation for a hyperbola with vertices here and foci here. So if we look here and here, just compare. So here, the y values are all 0. And if we look up here, here the y values are 0. So you know it's going to be horizontal. And so it's this formula right here that we're going to be using. Now look at the vertices. The vertices are at plus or minus 6 and then 0. Here this is plus or minus a and then 0. So based on this, we know that a is 6. And the foci are at 8 and negative 8. So according to this, 8 must be c. Now if you're looking at this formula, we don't put c into the formula. We need b. So that's where this equation comes into play. So we use c squared equals a squared plus b squared. And then we can solve for b. We'll be able to plug everything into our formula. So 8 squared is 64, 6 squared is 36, And then to get b squared by itself, we subtract the 36 from both sides. So 64 minus 36 is 28. So that's b squared. Now I don't need to find b because my formula wants me to use b squared. So it would be pointless to square root this just to square it again. So let's copy everything down. So x squared over, now a squared is 6 squared, which is 36, plus, minus, I'm sorry, y squared over b squared, and we know now that b squared is 28, and that's equals 1. So that is our equation right there. Okay, let's look at another example. This time we are given the asymptotes, and it tells us that it's a horizontal hyperbola. So we know we're going to be using the first equation. It's off the screen now, so let me just pop that right here. Okay, so if we look at the asymptotes, 7 over 9 and negative 7 over 9, so they're supposed to be b over a. So that means that a is 9 and b is 7. And the vertices are 9, 0 and negative 9, 0. So that is just more confirmation that a is in fact 9. So we plug those all in. So we've got x squared over, and then a squared would be 9 squared, which is 81, minus y squared over b squared, 7 squared is 49. That one was actually pretty straightforward. We basically just used the equations of the asymptotes to very quickly figure out what a is and what b is. Okay, so that's the first round, when we are centered at the origin. When we flip, we are no longer going to be centered at the origin. So these ones, just like my parabolas, just like my circles, just like my ellipses, these ones are centered at the point hk. So if h and k were both 0, you can see this would just be an x squared and this would just be a y squared. So we're moving them a little bit. They are now going to be centered at a different points. We can still fill in a lot of the same information. So here, because the x comes first, then minus y, this one's horizontal. This one here, the y comes first, then the x, so this one is vertical. Now remember, the foci used to be plus or minus c right here, but we were starting at 0, 0. So now we start at h. Whoops, this is not right at all. Sorry. Okay, so it's centered at hk, so the center starts at h, then we go plus or minus c, and then this value is k. Now here for the focus, we're going up and down c units. So the x value is just h right there at the center, and then from k we go up or down c units. So this is very, very similar to what we had with the ellipses and with the hyperbolas actually, and with the parabolas. The vertices, you start at the center value of h, and then you go up or down a units. Then the y value is just k, right where we started. For the vertical ones, we start here at the center, and then we go up or down a units. So the h doesn't change, k goes either up or down a units. The covertices, horizontal means my covertices go in the vertical direction. So I start at hk, and I go up b and down b. So my h doesn't change, but k can go up or down b. Here I'm vertical, so my covertices go left and right. So from h, I go left or right b units, and then I stay right at k, because I didn't go up or down. And finally, my asymptotes, these ones are a little bit tricky. Since my center, I use y minus k instead of just a y. I'm going to replace the y in this equation right here. Y equals plus or minus b over a times x, which I had in the previous page. I'm going to replace the y with y minus k equals, I still have plus or minus b over a, but I'm going to replace the x with x minus h. Because the x on the previous page got replaced with x minus h here, and the y in the previous page got replaced with y minus k. Then I'm going to do the same thing here. Replace the y with y minus k. But for the vertical ones, my slope was plus or minus a over b, not b over a. And I'm still replacing the x with x minus h. So that's all my new stuff. That's if I move my center. And remember, this still applies even if my center was 0, 0. For example, here, let's say my center was 0, 0. This would be 0 and then 0 plus or minus b, which still gives me exactly what I had here, 0 and then plus or minus b. So let's graph. Graphing, I love graphing hyperbolas and ellipses. This is probably my favorite part here. So we're going to start by kind of identifying all of the important information that we need to graph. So our center, the x value is the opposite of what I see here, so it's -3. And the y value is the opposite of what I see here, so it's +4. And then under here, this is where I go in a vertical direction. Okay, so in a vertical direction, I'm going to go 3 units from my center. That's basically how I'm going to find the vertices for this. So I'm going to go 3 units in each direction. Then in the horizontal way, this is supposed to be b squared, but I want to find b. So it's 25 is b squared, then b is 5. So I'm going to go 5 units in any direction. So we're going to use that to set up the graph. So start with just plain old coordinate axes here. Go to your center. So -3, it's 3 units to the left, and then 4 units up. And so since the center really isn't a point on the graph, let's just kind of mark it. Say like, all right, there's the center, and then everything comes from there. So this one, I have y first, then x, so I know that's going to be vertical. So my transverse axis, I'm going to go up 3 units and down 3 units. So I'm going to go up 3 units, kind of put a little mark there. Then I'm going to go down 3 units, you can put a little mark there. So this is going to be my transverse axis of symmetry. All right. Now for my co-vertices on my conjugate axis, I'm going to go 5 units to the right and to the left. So 1, 2, 3, 4, 5. Again, put a little mark right there. And then 5 units left, 4, 5. So right there. Now, let's take a look at this picture in the book again. So see, we've got vertex here, co-vertex, co-vertex. See how the first thing they did was they made a little dotted box here. Little dotted box, and then they used that to guide where to draw their asymptotes. That's exactly what we're going to do here. So out of these little flecks that I just put in here, we are going to use that, and you want all these to be dotted lines. So you're going to make a little box out of dotted lines. Okay, so we start there, and notice our center that we marked is right in the center of that box, and then our asymptotes will go through the corner, through the center, and then out the other side. So these are our asymptotes. And then we're going to have another very similar one on the other side here. And they've got to be dotted, because if they're not dotted, then they're part of the graph. And they're not part of the graph, they're just helping us to make the graph. Okay, so now this one I know is vertical. So let's look at this. What my graph does is it glides right along the right along the asymptotes, hits the vertex, and then glides back along, and then you've got a very similar piece down here. So that is exactly what we're going to draw in. We're going to glide right along this line here, hit this point that I marked, and then glide right back along in the vertical direction, and then the other one here hits that point, and then glides right along over here. So that is my hyperbola, just this dark part that I drew here, the actual solid line. Now you never ever erase those dotted lines, because otherwise it looks like you just kind of made up the hyperbola yourself without any guidance from these asymptotes. So vertices. For my vertices, I know I started a value of -3, 4, but from the 3, I guess the -3 stayed right where it was. From the 4, I went up and down 3 units. Okay, so my vertices are -3, 4 plus 3 is 7, and -3, 4 minus 3 is 1. And if you look at the graph, that's exactly where I put them. -3, 7 would be right here. -3, 1 would be right here. So those are my vertices. Next, the 2 foci. So I know we've got this formula, this formula right here. So we need to find C. So when we find C, we know they're related by C squared equals A squared, which is 9, plus B squared, which is 25. So that's 34. So here I actually do need to find C. So here all I do is square root both sides. So C is a nice, neat square root of 34, whatever that is. Just leave it. It's fine. So I'm at my value of -3, and then from 4, which is my center, I'm going to go up and down root 34 units. So there are 2 different points kind of nestled in there. And then finally, my 2 asymptotes. So we use this formula right here. So y minus, right here, 4 equals, and then plus or minus b over a. So here, b is 5, that's the square root of 25, and a is 3. So plus or minus 5 over 3, and then in parentheses I have x plus 3. So basically, like, this piece right here goes right here, and this piece right here goes right here. All right, so those are my asymptotes. So 3 things to come up with. So 2 quick changes to the notes. We're not going to define constant difference. It's not something that I'm ever really going to make you apply. It's more part of the formal definition of a hyperbola. That definition is in the book. If you are interested, I absolutely suggest that you go if you're curious. And then lastly, this problem right here, just forget about that. We're not going to do a story problem. I'd like to have you do a different type of example that you'll see in your homework, and you'll get a little bit more practice graphing. So what I want you to do is graph this. So 25x squared minus 4y squared minus 100x plus 48y minus 144 equals 0. So this is in what we call standard form for a conic section. You'll see some that are given to you in that form, and first thing you have to do is get it into like what a hyperbola function actually looks like. So that's your first job. And we did something just like this with the ellipses. And what we did was we gathered up all the x stuff. So like here's x stuff, and you make a group out of it. And then you gather up all the y stuff. So here's some y stuff, here's some y stuff, and you make a group out of that. And then finally we take any constants and we banish them over to the other side. Okay, so let's start with our x group. 25x squared minus 100x. Remember from the ellipses, what we're trying to do here is complete the square. One of the main things when you're starting to complete the square is that you're not allowed to have a number right here. So whatever is right there in front of the x squared, I'm going to factor it out. Okay, I'm going to keep everything color-coded. So here's my x stuff. I'm going to factor out a 25. So if I factor out a 25 here, all I'm left with is an x squared. If I factor out a 25 here, I'm left with minus 4x. Now, we know we've got an extra step that we haven't made it to yet, so just leave a blank spot there. Then my y stuff. Here, I'm not allowed to have anything in front of the y squared either, so I factor out that negative 4. When I factor out a negative 4 here, I'm left with y squared. Be careful with this term. If I factor out a negative 4, I'm left with a negative 12y. And then again, we're not done, so leave a space there. And then this is equal to, now I would add 144 to both sides. So I'd have this constant just floating right here. Okay, so that's taking everything that I've got up here. I haven't changed a thing. All I've done is rearranged and kind of manipulated a little bit. So now inside this set of parentheses, remember the completing the square step is I cut this in half and then square it. So half of negative 4 is negative 2. And then if I square it, I get positive 4. So I'm going to add plus 4 right there. And then remember, we've been doing this for a couple days now, this isn't a 4. It's 4 times 25. So since I just added 4 times 25, which is 100, I have to balance it out on the other side. Okay, keep everything in balance. And then here, same thing, I take this middle number, the negative 12, cut it in half, I get negative 6, and then square it, and I get 36. But again, this was not a 36. This is a 36 times negative 4, which is negative 144. Since I technically added a negative 144, I'm going to put one on the right-hand side as well. Keep the balance. Okay? So now let's rewrite. So I've got my 25 on the outside. Don't forget about that. And then this right here, x squared minus 4x plus 4, that factors down. So what multiplies to 4 and adds to negative 4? That would be negative 2 and negative 2. So I write it as x minus 2 squared. Remember, our quick trick is that it's half of negative 4. Minus 4, and then this thing factors down as well. What multiplies to 36 and adds to negative 12? That would be y minus 6, y minus 6. And then equals here, the 144 cancels with the negative 144. I have 100. I am super, super, super close to my final answer. What I do here is I need this to be a 1 for my final hyperbola form. So I divide by 100 just like with the ellipses. And so this becomes Here I've got x minus 2 squared, and then 25 over 100 reduces down to 1 over 4, minus, and then y minus 6 squared over 4 over 100 reduces down to 1 over 25, and then I have my 1. So now that is a hyperbola in perfect hyperbola form. All right, so let's write down everything I need. So my center is the opposite of this and the opposite of this. And then A, that is how far I go to make my transverse axis. So A is the square root of 4, which is 2. So I'm going 2 units in the x direction, which is horizontal. Then to make my conjugate axis, I need B. So this is B squared, which means that B is 5. So from the center, I'm going 5 units in a vertical direction. So let's put our sketch over here. Okay, so start at this center, 2, 6. Okay, so again, it's not really a point on the graph, so all I'm going to do is just mark it so we know it's there. Then this is it's a horizontal one, so it opens to the left and to the right. So for my transverse axis, I'm going to move 2 units left and right. Mark a little spot right there. And then for my conjugate axis, I'm going to move 5 units up and down. So down 1, 2, 3, 4, 5, and then up 1, 2, 3, 4, 5. Okay, now these 4 points that I just dotted in, we're going to use them to make our little dotted box, and we're going to use that to draw the asymptotes. Okay, so now through the corners here, draw your asymptotes. Through this corner here, and then we know it opens left and right, so glide right along those asymptotes through this point and out the other side. And right along the asymptote through this point, oops, went into the box, sorry, and out the other side. Okay, so since we're already running pretty long, let's find the vertex, the foci, and the asymptote lines when we are in class together.